Previously on Beyond Ideas.
Whatever reality is, you don't see it. You see a user interface. Physicists are saying space-time is doomed. There's no such thing as space-time fundamentally in the laws of physics. The reason why we have a user interface is because we don't want to know that quote-unquote truth.
Professor Donald Hoffman challenges one of the deepest assumptions in science, that space and time are fundamental. He argues that what we perceive as physical objects like particles, atoms, or matter aren't actually the building blocks of reality. Instead, what truly lies at the foundation is change itself. Not matter, but the evolution of states.
There are an infinite number of directions in which you can go infinitely far in more and more complicated consciousnesses.
And beyond the limits of space-time, he claims, we find structures, astonishing structures, geometric entities like the amplituhedron, fusion simplices, and what he metaphorically calls obelisks.
So we've been looking outside of space-time for 10 years, and what do we find? What you take off that, what's it? Obelisks, geometric structures sitting there. Here I am. Could be millions of dimensions, it could be trillions of dimensions, they're just sitting there.
Or, if we take it to the extreme, this is what might exist outside the interface we call space-time. And that is just the beginning. So let's delve deeper into today's topic. Donald Hoffman once posed a deceptively simple question. Do we see reality as it is? The question points to something deeper, perhaps a sign that one of our core assumptions might be wrong, and that fixing this assumption might finally help us understand the nature of reality. Now, some skeptics suggest we may never solve this mystery, that perhaps our brains just aren't built for it, like monkeys trying to solve quantum mechanics. But Professor Hoffman is more optimistic here. If our brain is the device we use to interpret reality, then perhaps it's time we study the brain itself. And all this starts with neuroscience. Neuroscientists tell us that a third of our brain's cortex is dedicated to vision. Just opening your eyes activates billions of neurons and trillions of synapses.
Well, neuroscientists tell us that they're creating, in real time, all the shapes, objects, colors, and motions that we see. It feels like we're just taking a snapshot of this room the way it is, but in fact, we're constructing everything that we see.
But here's the twist. Vision isn't like a camera. Yes, your eye has a lens. It works like a 130 megapixel sensor. But your brain isn't recording reality. It's constructing it. You don't construct the whole world at once. You construct only what you need and when you need it. If you're still not sure whether the perception he's talking about can be trusted, well, let's try a few visual illusions. Here's the first picture. There's actually no triangle, but your brain is inventing it to make sense of the negative space. The second one. This static image appears to move if you stare at it long enough. And so motion is an artifact of your brain's refresh cycle. And the last one, perhaps the most interesting of all. Which of the tiles is darker, A or B? You might think it's A, but actually, they're the same shade of gray. Your brain compensates for lighting, even when it's wrong. Speaking of color, did you know that color simply does not exist in nature? That green in the grass, blue in the sky, and golden hue in gold, if you zoom in close enough, down to the atomic scale, you'll find that color simply isn't there. At the level of individual gold atoms, there's no visible goldenness to them. Just arrangements of protons, neutrons, and electrons. No color pigments, no shimmer. So then, where does it actually come from? Well, it turns out what we call color is just our brain's interpretation of different wavelengths of electromagnetic radiation. We all know about the visible spectrum we learned in high school: violet, indigo, blue, green, yellow, orange, and red. They're just a narrow slice of wavelengths our eyes evolved to detect. When light with a certain wavelength hits the retina, it triggers a cascade of electrical signals, and then the brain does the rest. It labels those with an internal experience, like red, green, or blue. And so that experience doesn't come from the atoms, it comes from us, constructed entirely in our mind. So if there's an alien species hovering above Earth, their red might not be anything like our red. In fact, if their wavelength spectrum extends far beyond ours, they might see things in your kitchen that appear completely invisible to you. Like when you heat up a bowl of soup in the microwave, they might perceive a glowing radiation of energy coming from within. So the only conclusion left is that what we see, even something as basic as color, is not a direct reflection of external reality. It's a construct, a custom interface built by your brain. So what else might be out there, just beyond the range of our perception? It turns out the internet works the same way. What most people see online, it's just the visible slice. There's a whole digital spectrum that's blocked, filtered, and geo-locked, unless you know how to tune in. The question is, how? And this is why we partnered up with Private Internet Access for this video. It's a virtual private network that helps you break past the surface layer of the internet. It encrypts your connection and gives you the freedom to access content from anywhere in the world. I tried to rewatch the BBC series Sherlock on Netflix, but found out that I wasn't able to access it from my country. Now, with Private Internet Access, I can change my IP location to the Netherlands, for example, and immediately unlock the series episodes, all accessible instantly. It works on all your devices, supports unlimited connections, and they have a strict no logs policy, meaning they don't record what you do, ever. So if you're the kind of person who believes that what you see isn't always the full story, check out this tool. Right now, they're offering Beyond Ideas subscribers a massive 83% discount. That's just around $2 a month, and you get 4 extra months completely for free. Just click the link in the description. And now, back to the real layers of reality with Professor Hoffman.
So what evolution gave us was perceptions that guide adaptive behavior, and part of that process, it turns out, means hiding the truth and giving you eye candy. Our space-time, 3 dimensions of space, 1 dimension of time, is a fairly trivial headset.
That sounds interesting. Why are we only equipped with senses to comprehend 3 spatial dimensions and 1 temporal? Why not 6 or 7 spatial dimensions? Or why not double timelines running in parallel? And these connections between events that we perceive as time are actually just part of the fabric of reality.
What could time be if it's not the way we experience it? What could it be pointing to? Time and causality appear to us the way they do because for whatever reason, we're only perceiving one moment at a time.
Later in this video, we'll explore what perception could look like if we were built to comprehend extra dimensions, other than the ones you're familiar with.
Even though time would be an illusion and the causality in the way we experience it is an illusion, it's still pointing to a deeper structure. There's something that it corresponds to in the fundamental nature of reality, that our perceptions map onto something. It's just not the experience of it that we're having.
And so this line of thinking leads to a compelling possibility that the reality we experience might not be the original structure. It might just be a projection, a simplified version of something more fundamental, something that is rendered into a format we can comprehend. And if that's true, then we should ask, is there anything in nature, any physical phenomenon that works exactly like that? Anything at all? Where a lower dimensional surface encodes a higher dimensional reality? As it turns out, there is something called the Blackhole's holographic principle. The concept is actually quite intuitive. Without diving too deep into the math of theoretical physics, the holographic principle suggests that everything inside a region of space, whether a black hole or potentially the entire universe, can be described by information stored on a lower dimensional boundary. This idea originally came from a puzzle in black hole thermodynamics proposed by Jacob Bekenstein and Stephen Hawking. They found that a black hole's entropy is proportional to the surface area of its event horizon, not its volume. The larger the surface area, the more entropy it contains. And as we all know, entropy is one of the metrics used to measure the information content of an object. And so, this led to a provocative conclusion. Everything that falls into a black hole might not be lost inside, but instead, its entire informational content is encoded on the surface, just like a 2D hologram that stores a 3D image.
It is possible mathematically to encode information about three-dimensional systems on two-dimensional surfaces, of how all the information on the one hand could be on the horizon of the black hole.
The idea that all of reality could be contained in 2 dimensions, and there's something about the interaction between different points that cause this holograph, so that it seems like there's a 3-dimensional world when in fact that it's a projection of this 2-dimensional surface.
In simple terms, everything that happens in a 3D space can be fully described by information stored on a 2D surface. And so, going back to the idea that our reality might be a projection, what if everything we experience is actually embedded in a lower dimensional representation within a higher dimensional structure? Something like a brain in string theory terms.
Once we let go of our massively intuitive but massively false assumption about the nature of reality, it opens up new ways to think about life's greatest mystery. I bet that reality will end up turning out to be more fascinating and unexpected than we'd ever imagined.
What he proposed was nothing short of remarkable. Space and time are part of the headset, a user interface that hides the true nature of reality. We don't see reality as it is. We see what we need to survive. So then, the real question is, if you could step outside of space and time, outside of the projection, what kind of structure would you encounter? Let's explore this in depth, coming up next, right after this. According to an article written by Professor Hoffman and colleagues titled Fusions of Consciousness, he proposes something pretty bold: that consciousness is the foundational fabric of reality. Not space, not time, and not matter. The entire physical universe emerges from the complex web of interactions among conscious agents. So, Professor Hoffman says that we should stop treating physical objects like particles and atoms as if they're the most basic ingredients of reality. Instead, what is fundamental is how things change and the probabilistic structure of those changes. So rather than asking what is reality, he asks, how do states evolve from one to another? And this is where something called Markov processes come in. They're basically the simplest model we have to describe probabilistic change over time. A Markov kernel, for instance, tells you, given that I'm in state A, what's the probability I move to state B? Let's say that you're a very simple creature with only 2 possible states of mind, calm and alert. Every moment, your state might stay the same or switch with some probability. That behavior can be described with a matrix like this. If x equals 0.9, you stay calm 90% of the time. And if y equals 0.3, when you're alert, you go back to calm 30% of the time. So this matrix Q is a single point inside a bigger mathematical object called the polytopes M2, which is the set of all such 2x2 stochastic matrices. But it doesn't stop here. Since this whole fusion of consciousness is really about dynamic systems and change, so what happens is that Hoffman introduces a dynamic law, something called kernel flow. In kernel flow, the values of x and y evolve over time, depending on how far they are from the fusion line, this line right here, a condition where the 2 states become fused, aka two experiences blending into one. This red path shows how this transition matrix evolves under the proposed dynamics. And so your calm and alert agent flows toward a new behavior, possibly one where the two states become indistinguishable. Now, what if you have three states instead of two? Well, in that case, the projections of these marker polytopes would look something like this in 3D space. So here's the key idea. When you collect all possible n by n stochastic matrices, you get a geometric object, a polytope living in a high-dimensional space. Each point inside this polytope is a valid world of transitions, and its shape encodes how systems can evolve over time. In fact, with just a little bit of a Python script, we can visualize how these Markov polytopes would look like in 3D space. And so you can think of this as the area where reality lives, just like how physicists use space-time as the arena for matter and energy. So the bold claim here is that Professor Hoffman argues that this space, the space of kernels, transitions, and fusions, is more fundamental than space-time. This brings us back to the bigger picture, that beyond our conventional understanding of space and time, there might be a deeper realm composed of intricate geometric structures, structures that Professor Hoffman metaphorically refers to as obelisks. Things like the amplituhedron, tetrahedrons, fusion simplices, and so on. A kind of structure that is not situated within space-time, but exists outside of it entirely. And this, as he claims it, represents a deeper level of reality. And yeah, maybe the objects don't intrigue you for one bit. But what if we can just let our imaginations run wild and see all these shapes that exist outside of space-time, being imagined by none other than the power of artificial intelligence? So here's what it looks like. Now we're getting into one of the more mind-bending consequences that Professor Hoffman briefly mentioned. The idea that this whole structure of reality might stretch out in an infinite hierarchy of consciousness.
There are an infinite number of directions in which you can go infinitely far. Think about it like the Twitterverse. There are millions of users and billions of tweets. There's no way that anybody could read all the tweets or interact with all the users. So we have to have something to make it understandable. What we'd like to have is some kind of like headset that allows us to see what's happening in Wisconsin versus Tokyo or whatever. And that's what space-time is. It's just a little headset.
So what does that actually mean? I think it's best if we bring it down to something more relatable, like the Twitterverse analogy, or as we should probably call it now, the Xverse. So imagine yourself as Alex, 27 years old, living in Bergen, Norway. You're sitting in a coffee shop, just about to head to work, and you post a photo of your cappuccino. That's it. Your moment, your state of mind. In that instant, your experience is just that one picture, that one post, your 3 spatial dimensions, and 1 slice of time. That's all you've got. Now, let's add a little bit of a twist. What if you could also experience life as Brenda, someone else entirely living in Palo Alto? While Alex is winding down for bed, Brenda is just waking up, posting a picture of her jasmine tea. And now imagine that you, somehow, are both of them, seeing both posts, both timelines, all at once. I mean, you're not just switching back and forth between perspectives. You are simultaneously holding both streams of experience, 2 different spacetimes, inside one field of consciousness. According to Professor Hoffman, that's what happens when 2 conscious agents combine. They don't cancel each other out. They fuse into a more complex agent, one that contains and integrates both. Now, what if we take that crazy idea and push it even further? What if it's not just Alex and Brenda anymore? Like you're not fusing two consciousnesses, but hundreds, thousands, maybe even all of them. What does it feel like to be the entire X-verse? Well, you'd be perceiving every post, every thought, and every photo from the day the platform launched in 2006 up to now in 2025. You're not just looking at the feed, you are the feed. You're a 70-year-old veteran in Maine, United States, and at the same time, a third-generation Vietnamese revolutionary in Hanoi. You're a Maasai elder in Kenya tending cattle at dawn, and a K-pop fan in Seoul live-streaming a concert. So every shared image, every comment, every fleeting moment, all inside one unified stream of experience. That's what it might mean to scale consciousness upward. You're not one person navigating a network, you are the network.
Consciousness, what it's up to is exploring all of its potentialities. And the reason it's continuing to do that is because there's no end to it in principle.
And that's where this idea starts to resonate with something else, a short story called The Egg. I guess some of you may have heard of it. In the story, a soul is told that it has lived, or will live, every single human life that's ever existed. You're not just one person, you're everyone. You're both Genghis Khan conquering Europe and the little kid in Mongolia centuries later reading about him in a schoolbook. You're a Nazi soldier in 1940s Poland, pulling the trigger on a Jewish father in front of his family. And then, you're that father's son who survives and emigrates to Israel, whose grandchild, now a third-generation Israeli, joins the military and fires into a street in Gaza. But you're also the kid in that little Gazan alley, not understanding why the bullet hits your stomach. All of it, somehow, is you.
The entire life of Hoffman is one trivial perspective on who I really am. And each one of the billions of human beings is an important, but compared to the whole, trivial perspective on what the consciousness is.
And maybe this isn't just a story. Our whole discussion today suggests that it could be part of the deeper structure, that consciousnesses can scale, fuse, and span across what we thought were separate lives. If that's true, then at some point when you die, when the headset finally lifts, you see the whole thing. And that's where this idea starts to resonate.